All right, there are three things we want to do. We need to set up an integral to find the length of the curve. We need to graph the curve to see what it looks like. And then we need to use our integral program to actually find the length of that curve. But in order to find the length of a curve, I need to solve for a certain variable. Now, if you notice here, we have a y squared. And if I solve for y, that means we're going to get plus or minus the square root. And I really don't want to deal with that. So I am going to actually solve for x. So I'm going to subtract 1 to both sides and then divide by 2. So I get y squared plus 2y minus 1 equals 2x. So x equals 1/2 y squared plus y minus 1/2. Now, I'm going to graph this to see what it looks like first, just because I'm curious. So I'm going to do that second part first. So I'm going to go on my 84, and there's several ways to do this. One way to do it is to actually graph it with respect to x, since this can only do y, and then just know that my x and my y's are going to change. So if I graph this, I know that my curve is actually going to look, instead of -1, -1, it's going to start on -1, -1. And then this point right here, so a little bit 0 is going to be a little bit 0 here. So my graph is going to look something like this. To make it, if you actually want to graph it on your calculator, what we're going to have to do is we're going to have to go to Mode. And we're going to have to go down to Parametric and select that instead. So when I get this, what I'm going to do is I'm going to actually graph x as a function of t, because when I hit the variable, it's going to be t. But then I just make y equal t, which means every time I see a t, these are actually y's. So if I graph this, it ends up giving me this, but that's not the whole thing. So what I need to do is I need to go back to my window. And if you notice, your t-min is 0, but I want my t-min to start at -1, because I want my y value to start here. So I'm going to go -1, and then I'm going to graph it. If you notice, now we have the whole thing. And if you want to zoom in on exactly what we're trying to find, we can go zoom. No, actually, we want to go to the window, and we want my x-min to be -1. I want my y-min to be -1. And I want my y-max to be 3. So if I graph this, you end up getting exactly that curve that I'm trying to go for. It's right there, right there. That's the length that I'm trying to find. So if I put a string on this length and then straighten it out and then measured it, that's what I'm trying to find. All right. So that is the graphing part. So if I want to find the length of the curve, I need this equation right here. And I'm going to use this one with respect to y, since this is going to be a function of y. But the first thing I need to do is I need to find dx dy. And dx dy is just this equation with respect to y. So I'm going to derive this. So that's going to be y, and then plus 1. So if I plug it back into my thing, the length of my curve is actually going to be the integral from my y values. So it's going to be from -1 to 3 of the square root of 1 plus y plus 1 squared dy. And that is my integration that will find the length of that curve. Now, to actually find a decimal approximation, we need to pull out our calculator again. And we need to go to a calculator page, and then we need to go alpha F2. And then the function integration is right here, so it hit 4. And it'll give me this, and so I put -1 to 3 of the square root of 1 plus parentheses, make sure you remember your parentheses. And I'm going to put x just to make things, oh, well, I guess it's t now because we're in parametric. But it doesn't matter. It'll give us the same value. Squared, and then d, my variable. And enter. It looks like it's going to be 9.29, and then this will round to 4. So 9.294.